Hello, everybody. I guess welcome back. We're going to be starting to deliver our classes again starting Monday of next week. The spring break, the extended spring break will be done, and online and face-to-face classes will continue, but everything will be online going forward. So I'm recording this for both of my CAD graphics classes, both the in-person that will now be online as well and the online class. And I just wanted to cover some things that we're going to be concentrating on this week. So this week is about creating drawings based off of some isometric views, which we haven't really done yet. All of our drawings so far have been drawings that you've been recreating exactly the way you see them from the handout. What's a little different about this one is you're going to be picking two drawings from this sheet, but everybody has got to do this cutoff holder, and you're going to pick one other drawing to do here. So you can see that the values next to the drawings are a little bit indicative of what they're worth. I'm not using quite the same numbering system, but if you go back, if you go back to here, you can see that some of these drawings are weighted a little heavier than others. So the locating finger and the toggle lever are worth a little bit more. The index slide and the chuck jaw are full points, and then the frame guide is a little bit less because it's the least challenging of all of the other parts to choose from. So if we go back to our 6 parts, the locating finger, index slide, toggle lever, cutoff holder everybody's doing, and the chuck jaw, and then the frame guide is the least challenging. So what I wanted to talk with you about was there's really 2 things you're going to be doing. You're going to determine how many views each one of these objects needs, and I'm going to give you a clue to that right now. And then you're also going to apply dimensions to these objects. But the challenge is when you dimension something that's in an isometric format, it's not going to be the dimensions will not appear in exactly the same way in your multi-view drawing because there are some rules and standards to follow. So I'm going to break this up into a couple of videos to show you, but let's start off with understanding how we would select our views. So I'm going to open up a PowerPoint, and I'll make sure the PowerPoint is also included in the lecture material. But for now, I'm just going to grab it off of the website. Not website, I'm sorry, but off of our server. So I want to look at orthographic projection. So in orthographic projection, we learned that each view belongs in a certain position. The rod support, for instance, we set up views that are front, top, and right side views. And the other kind of projection that we see in other parts of the world is first angle projection. So you'll notice some familiar shapes here. So this is going through the ways that you pick out how many views something needs and what should be its primary view. So this is the frame guide, and this is suggesting that we would put the views in this order. And this would work okay, but one of the problems I have with this particular order is that one of the features that we're trying to see and that we're going to have to add dimensions to is this arch right here in this right side view. And I'm not able to see it very well with the way that things are laid out. So what I would do is take this view and mirror it in the opposite direction so that these 2 views here are facing opposite direction, and we are able to see this view so that the arch is showing in its true shape in the right side view. So this is what that would look like. So my suggestion is we do something like this instead. So you see that the information that we see in the top and the front view is the same. It's just we're seeing it from the other direction. But the way orthographic view projection is set up, this object now gets turned. So we're looking at it from this direction, and we're able to see the end of the frame guide where we can see the feature clearly without it showing up as hidden lines. Notice too that I'm not including the object line information or the additional hidden line information past this point. So if you can imagine there's an imaginary line like right here where we can't see past that plane, we're ignoring that information, and this is called a partial view. But everything else you see here would be set up properly. You can see that the lines that we draw here are going to be projected from where these two lines would have originally intersected. So I have a fillet here, but if I actually intersected this line with this arc, this is where that intersection would be, and that's where I projected the top line to in this top view. So those are some of the things that we want to consider with that particular object. In the next object, we have the toggle lever. And you can see that the primary view that we've chosen is the one that the most information is being shown in this view. So this is the most detail example of picking a primary view with the most detail. We still need to see these other views because in this view, this is the only way that we can actually see the shape of the notch or the reason why this hidden line is showing up in this front view. And then in the right side view, this is the only way that we can actually see the shape of this feature here from the right side view so that we can see that information. But I do want you to notice and pay attention that there's a lot of extra line work here and all of these hidden lines that are showing up. We want to see where those hidden lines are showing up. If I were to draw a line from the quadrant here of this arc all the way across, it would run into that hidden line. If I wanted to find out where this arch hits this line edge and project it over to this view, that's where that hidden line would be. And lastly, the edge that I have here, this flattened edge, is where this edge would be. The hidden lines that I have going in this direction would be projected through the miter line and then down, creating these hidden line features. Down here, I have to project from the hidden line over. And you can see it would line up with the line just above the baseline here. Go into just above the baseline here, so this line. And then if I project from the quadrant, then I'm going to get this line here. And then if I project from the bottom edge of this feature, I get this line. So you have to make sure you're projecting from each one of these points to figure out where all these lines are. So notice that there's a little dip here. That dip is from the quadrant of this feature, is going to find where this line is. And if I project from where this, again, this arc hits the edge of this part, if I project up like this, I'm going to see where that line would actually end. So there's a lot of little futsy things that you're going to have to pay attention to get it to come out correctly. All right, so let's look at the next slide. The next slide, it talks about how important horizontal format is. And this is important because we usually are going to set our drawings up on a sheet of paper that's set in a horizontal fashion, or landscape it's called. So if I pick this as my primary view, it's going to fit better on the sheet. Having this be my primary view, it's a longer, wider view, so the top view is going to fit above it quite nicely, and then the right side view is going to fit next to it, creating more of a horizontal format. If I were to choose this view as the primary view, then the top view changes direction, and the right side view changes direction. It's taking up more of a portrait kind of shape to it, and so it won't fit as well on our landscape formats. In the next example, if we were to flip this around, and so why don't we just show it from the other direction like we did with the frame guide? Well, in this scenario, it doesn't work as well because we end up with more hidden line features than we'd like. So in this one, we see the raised surface area here and these fillets as an object line, but here we see them as hidden line, and it might be a little bit confusing. So unless we decide to show this as a partial view and get rid of all of those hidden line features in this view just to show what's going on with the whole, then it's possible that we can make the argument that this would work. But this is a better choice in this example because of how simple the part is. And the last thing that we look at is view stability. So if you take into consideration how this part is being used, in this case, this is a tooling part. It sits like this as a tool, and so it should be sitting in this direction. We call this the front view. That would be the top view. This would be the right side view. And this feels unstable to us. And if you actually saw the part, it would actually flop down being held in this position. I guess the idea being here, if we picked this view, we would be able to show these feet here on the bottom as object lines rather than hidden lines. But the gain is not there as far as understanding how to read the object better. Now, if this part was mounted on a horizontal surface above us and actually hung out like this in the upside down direction, then maybe it does make sense to show the part in this way, but that's not how it's used. This is how it's used, so this makes more sense to lay the part out like that. So that's some insight there as to gives you some very good ideas of what these drawings should look like as finished drawings, depending on which ones you choose. So I wanted to go over that and go over and revisit orthographic projection. So to recap, these slides are indicating the 5 things that we go through to determine a best primary view, and how to create, after you've picked your primary view, that sets up what this view is going to look like and what that view is going to look like, because we just simply turn the object and flip it to see the object in the other views. So keep in mind how important that primary or the primary or front view it's called. So this one, true shape, means the most information about the object is showing up here in the true shape, most detail. Horizontal format, fewest hidden lines, and view stability are the things we look at. And that's how we arrive at what's the best choice for me to pick for a primary view. The objects that we didn't look at in this example are the index slide, so I'm going to go to that now. So with the index slide, that's one of the objects you could make the argument that we really don't need a right side view. And if you are curious, go ahead and project that right side view. I'm going to put on a construction layer and show you. I'll just use the DIMS layer for now. We'll use a miter line. Make sure that that's at a 45 degree. Yeah. If I just start to draw lines here to indicate what is going to happen here in this right side view, you'll notice that we end up with some information that doesn't really help us out a lot. Nothing is really being shown in its true shape. So that is what we end up with for a view. If I fill this out and show what would be object lines and hidden lines, you'd realize there's nothing going on there that helps us with anything that we need to add dimensions to or anything like that to help us with manufacturing or building the part. So in this particular example, we only need these 2 views. Now, in the index slide, we also have some projection things that we have to pay attention to. Once you draw this primary view the correct way, you need to project the quadrant of this arc to find the hidden line. And then you also need to project where the arc hits the edge of the object to find that object line. However, this arc is in the reverse direction. Where the quadrant is the object line, and where the edge of the arc is also going to be an object line. We're seeing a little bit of surface area of that arc here in this top view. Hidden lines are projected from the holes that we have here, so we can see that that quadrant right there lines up with where this hidden line is. And these 2 object edges here would create a hidden line here. And we have a hidden line here that's lining up with this edge of the circle. This little cutout that we have here is a result of us projecting from this edge to find the edge of the raised surface here, and then the actual edge of the frame guide. Some of the dimensions that are shown too can be confusing when we look at these drawings. We look at them in isometric format. I will point out some misconceptions people have. For instance, this locating finger is not angled back here. What that looks like is, it looks like this. So we have a flat edge. The angle you're seeing is a result of this circle being a radius or diameter of 32, I can't remember. And then you notice that the lines here on these three sides of the circle are tangent to it. If I were to turn that into a hexagon, I'm giving you guys clues here, turn it into a hexagon with 6 sides, and I made it a circumscribed hexagon. Do you see that it ends up being the bottom half of the hexagon down here that defines that part of the frame guide? So I could create a hexagon and trim it to the height here, and I'd end up with the shape that I needed. Now up here I left this blank because I'm going to show you in a new video what that's going to look like. So I just wanted to make you aware of some of the little ins and outs of some of these drawings and things that you're going to have to look for, and how to interpret and read those dimensions. So take a look at some of the additional lecture material. I'll go over each object to show you some specifics that you need to know.